Hi there and welcome to the Whistle Classroom. Today we're going to be talking about the laws of motion. The laws of motion are the fundamental underpinnings that describe everything that moves. Airplanes, people, boats, cars, bicycles, bats, you name it, they obey the laws of motion. They're fundamental, and by law we mean it's a set of facts that are always true about an object in motion. It's not really a recipe for solving a problem. It's more that if you know these facts and you understand how they relate to each other, you gain insight, which then allows you to solve the problem. The laws of motion were formulated by a guy named Isaac Newton. And you may have heard of him. He's the guy that supposedly sat underneath an apple tree. An apple fell out of the tree and hit him on the head, and he invented gravity. That story's probably not true, but he did come up with the laws of motion. And there are three of them. The first one you usually hear as an object at rest tends to remain at rest, and an object in motion tends to remain in motion. Another way to say that is objects have mass, and mass has inertia. What does that mean? Well, mass is the property of stuff. All stuff has mass, and inertia is the tendency of mass to not move unless it's pushed on. So we can illustrate that. Imagine you have a shopping cart and you're pushing your shopping cart. And you know that if a shopping cart is empty, it's easy to speed it up, and when you get to the end of the aisle, it's easy to slow it down. But if you fill your shopping cart up with stuff, some celery in there, it's much harder to get it to speed up, and it's much harder to get to slow down. If you really get it moving, you gotta pull pretty hard to slow it back down again. And that's because we added mass when we added stuff, and that added inertia. The second law tells us some rules for how forces and inertias and speeding up and slowing down interact. And this one is easiest to give as a formula. The sum of all the forces is equal to the mass of the object times its acceleration. And don't be afraid of the math. This is going to be a tremendously useful thing to have in our vocabulary. This funny thing here is the Greek letter sigma, which is basically an S, so that means sum, which just means add up all the forces. There's also little arrows on these because these forces and accelerations have directions. This force is going this way, and that means that the acceleration will also go that way. So when you add up forces that go in the same direction, either towards or against each other, tend to cancel each other out. So for example, if we have somebody over here who, for whatever reason, is pushing that way, call that F1 and that F2, we now can learn something by using this formula. Now if we just write it straight down, we can say F1, we'll call any force going this way, plus, minus F2, because we're going to call any force going the opposite way, minus, is equal to the mass of the shopping cart times its acceleration. Now if we happen to know that we're pushing, let's say, 50 something pounds of force or newtons or something like that, and the other person is also pushing with 50, if we add that up, 50 minus 50 is equal to 0. So that means that m times a is equal to 0. We know that m is not 0 because the shopping cart is full of stuff, so that means that a must be 0. That means that our shopping cart will not speed up or slow down. So if it's not moving to begin with, when we both push in opposite directions, with the same amount of force, it won't speed up or slow down. So that's kind of interesting to know. If I know that he's pushing less hard, then I know that this won't be true anymore. Suppose I'm pushing with a force of 50 and they're pushing with a force of only 40. So still always equal to ma, but now 50 minus 40 is 10. So that means that the mass times acceleration is 10, and the acceleration, if we divide both sides by the mass, equals 10 over m. that will tell us how fast it's speeding up and which way it's speeding up, because this is plus, and we said plus means it's going that way. Another useful thing to know is suppose two people are pushing on a shopping cart and we can see that it's not speeding up or slowing down. So we know immediately that this is already 0. And I know that I'm pushing with my 50 pounds, but I don't know what the other person's pushing with. I know this is 0 because it's not speeding up or slowing down. I know this. Do a little bit of algebra, and I can say that F1 is equal to F2, or in this case, we're both pushing with 50 pounds. Solving this problem another way. I know the forces, I can find the acceleration. I know the acceleration in one force. I can find the remaining forces. Incredibly useful formula. Use it all the time. All the time. Well worth your memorizing. Sum of the forces is equal to the mass times the acceleration of a free body. The third law, this is a little bit more subtle, and it's more about helping you to think about problems, I guess. You usually hear it as for every action there's an equal and opposite reaction. I like to write it as everything pushes back. And if you think about it, you're pushing on your shopping cart. The shopping cart's pushing back on your hands. That's what you feel is the shopping cart pushing back on you. We can think about that a little more easily if we imagine our shopping cart again. Only this time we're on ice skates, and so is our shopping cart. So it's really slippery. Our feet aren't keeping us from moving around. So if we apply a force to the shopping cart, according to this law, it also applies a force to us. Exactly the same amount, but in the opposite direction. And if we look at each of these individually, we can apply F equals ma and find out how much it's accelerating. So if I push on my shopping cart with a force F, the shopping cart is going to have F equals ma, and that means that A is equal to F over m, going that way. And this is the mass of the cart, by the way. Likewise, same force, because everything pushes back, is equal to the mass of me times the acceleration. If I solve that, then I get the acceleration of me is equal to the same force over the mass of me. So we can use this rule to tell us what happens in a situation like this. What's important to know, though, and if you're solving one of these problems, is that this rule only applies to 1/2 of each of these force pairs, if you like. Don't make the mistake of saying, I'm going to add up the forces. F plus, F minus, 0, nothing happens. Draw a little box around it. Find 1/2, get the thing moving by itself, and slice away any of the other force pairs. And that's how we get this one and how we get that one. So, 3 laws of motion, fundamental, use them all the time. Well worth experimenting with and thinking about. These are the simplest ways to describe them. You can apply them in all kinds of other ways, and we will when we talk more about airplanes. So we hope you enjoyed this. We hope you learned something from it, and we hope to see you again soon at the WhistlePig Classroom. Thanks a lot. Take care. Bye-bye.